Hello, and welcome to the Mentor Dino podcast. I'm your host, Katelyn Rossier. I am an architect and founder of Mentor Dino. Join me each week as I speak with amazing professionals in and around the architecture, engineering, and construction industry, as we are all part of a larger interconnected community. We discuss everything from career stories, lessons learned, and advice for others finding their own unique career path. Thank you to all of our current subscribers, and if you're new, welcome to the conversation. And if you like this episode, please do me a favor by hitting subscribe, like, or share it with a friend. It really helps others be able to discover this resource and support them on their own unique career journey. On this episode of the Mentor Dino podcast, we're talking about how you can take your career outside of traditional architecture and construction and engineering and funnel your energy into bigger initiatives associated with codes, policy, and frameworks part of the AEC industry. So this week I'm pulling together 3 episodes, and it's all different sides of code and policy to where you could take your career if this is something you're interested in. So I'm going to be bringing in Ricky McLain, who is episode number 36, and he is a heavy timber structural engineer and consultant. Corey Squire, who is an architect focused on sustainability, and Scott Farbman, which was episode number 80, and he bridges the gap between architecture and engineering on the policy side. So I'm really excited to introduce these 3 to you, and don't forget you can check out their full episodes if you want to hear more about their story, career, and how they got to where they are today and what they're doing. So first off, let's start with Ricky McLain. He is a structural engineer and focused on heavy timber. So he started his own consulting business, so you can bring in Ricky to your projects if this is the first time you're doing heavy timber. And talking about how codes and policy need to change with the heavy timber construction and how you can bring those into your projects, because it's not really a brand new way of construction, but in the States, it's coming back into popularity to be able to build in this way. And there are certain ways to do this in a more efficient way, whether it's cost, constructability, and materials. So Ricky can help you with that, and we talk a lot about the heavy timber industry in his episode. So let's jump over and learn a little bit from Ricky. Expanding on engineers figuring out their path, what advice do you have for structural engineers that are looking to get into mass timber, gain that type of experience, or trying to pull that into their projects? I know a lot of the structural engineers that I work with, I'm in an AE firm, so I do have structural engineers. A lot of them are excited about mass timber, and it's just getting that projects to come in the door and that initial experience. Do you have any advice for structural engineers looking for that?
Yeah, definitely. An analogy that I often like to use is it's, when is the worst time to start saving up for a house down payment? Let's say you're going to buy your first house. When's the worst time to start saving? It's when you already have one under contract, right? Because at that point, it's pretty much too late. You're probably not going to be able to get your mortgage unless you just happen to be sitting on a huge pile of cash. So similarly, in my opinion, when's the worst time to start getting up to speed or saving money in the bank, if you will, getting up to speed from a knowledge standpoint about mass timber? It's when you have your first mass timber project that comes across your desk. Because then, you're supposed to be doing your normal job of designing a structure while also learning this brand new structural building material that you've never worked with before. Not to say that mass timber structural design is incredibly complicated, but it is definitely different. And it's not just the calculations that you're running through, bending and deflection and all that stuff that take different forms. It is that, but it's not just that. It's also understanding how mass timber, number one, behaves differently. Things like it's quite susceptible to vibrations, and other materials may not be. But also understanding how to use it in a most cost-efficient manner. Because right now, mass timber is still having a lot of challenges on projects from a cost standpoint. there's a lot of interest in using it. Like you mentioned, some of your engineering colleagues are very interested in using it, but a lot of times those projects don't go forward because mass timber just is too expensive, or it was designed in a manner that maybe didn't use it most efficiently. So not only are you needing to run the calculations, you're also needing to understand the properties of the material such that you can use it very efficiently. So those are some of the areas where it really takes getting sort of a holistic understanding of mass timber. There's definitely some good information out there, in terms of like the actual structural calculation processes to go through. There's been a lot of, good papers written, webinars that are available, videos on YouTube, kind of the whole gamut. It does take somebody being willing to sort of put the pieces together and, understand, this document might be great for vibration versus that video was a great overview of how to check for, structural efficiencies and span lengths versus this connections manufacturer has a really good white paper on how to design connections and hangers, those types of things. But I would say understanding the landscape of the manufacturers, both on the product side, so like CLT, glue lam, DLT, the individual wood products, as well as on the connection side, so fasteners and hardware. I think understanding the landscape of who's out there, because it's not a huge pool at this point, and then take a look at their technical literature, understand how that can then start to be implemented, understanding it, so that ultimately what you're doing with all of this is getting yourself ready for the opportunity that is to come along, right? And that opportunity might come along just by happenstance, because the architect you're working with is trying to get mass timber used on a project. But that opportunity might also come along because you've gone through the process of learning mass timber, and then you can start to demonstrate that knowledge and expertise, which could be a way to attract work to your company, right? So I think it definitely makes a ton of sense to get up to speed now as opposed to waiting. Because like you said, a lot of people will want to hire an engineer with experience. But if that just means then the same structural engineers continue to do mass timber projects over and over again, it's never going to open the door for new ones to come along. So those new ones really need to get up to speed on the knowledge side.
Yeah, it's always a chicken before an egg thing.
Yeah.
Now, I know you mentioned efficiency with the design. When I think of that, I'm thinking like bay widths, or if there's standard connections that make it more affordable versus, architects creating crazy forms and then saying, all right, let's do it out of mass timber. I'm assuming it's more of a conversation on those efficiency points. Do I have that right? Or can you give me an example?
Sure. Yeah, and that's 90% of it for sure. When you look at the total, like if you were to get a bill at the beginning of a mass timber project from the mass timber supplier, and it kind of breaks down, this is how much the material costs, this is how much the connections cost, this is how much the labor costs to install it, all that stuff. The majority, usually, say 50 to 80% or something like that, of the total cost is the material itself, which is really the reverse of most structural products, which is the majority is the labor to install it. So majority is tied up in the material itself. So minimizing that material to the maximum extent possible is really the biggest way to influence costs. And so to your point about like bay sizes, it really goes hand in hand with understanding, like you talked earlier about the building code, understanding the code requirements for, what is the fire resistance rating. And I usually start there because if you're leaving mass timber exposed and it requires a fire resistance rating, which oftentimes it does, and you can leave it exposed still, but that influences the size of the members, right? Usually if you have sized a floor that's, X thickness and it needs a fire resistance rating, it might need to be a little bit thicker. So starting with the fire resistance rating to understand what does that mean on your member sizes, your beam width and your beam depth and your floor panel thickness, all those things. So that once you know that, like what's the thinnest it can be while still getting you your fire resistance rating, then you come up with your size, let's say your floor thickness. Then once you know that floor thickness, you can say, okay, based on this floor thickness, its maximum span is whatever, 14 feet, 18 feet, whatever that number is. Then can we lay out column bays that match that spacing or increment, or at least are very close to it? because it's inefficient to say have a panel that can span 18 feet, but you're only asking it to span 13 feet. Or it's also inefficient to say this panel can go up to 17 feet, but I really need my bays at 18 feet, because then you're going to have to go to a thicker panel, and that's going to drive costs up a lot. So yeah, it's understanding those, the influence that fire design has, first of all, on member sizing, and then what the influence member sizing has on span ranges or span ratings for the members, to really try to dial in and minimize the volume of wood. And then the second place you go typically after that is the connections, detailing the connections. How do these members come together? How can we simplify that process? Simplify and minimize the fabrication work that the mass timber manufacturer has to do, as well as make it a detail that is fast and easy to install on the job site. There's some, say, a beam to column connection. There's different ways to detail that. One method might take 10 minutes to install on site. Another method might take 25 minutes to install on site. Sure, it's not a huge difference, but if you have, 200 of those connections on the job site, that does add up significantly. So the time aspect, the cost and the time aspect of connections and details also plays into that efficiency piece that we talked about.
Yeah. Just like, I think it's good understanding all of the information you need ahead of time, because a lot of the times the architect will be involved in that early schematic design, sometimes by themselves, and the structural engineer will just be like, hey, this is what we're going to do, and that's how you would do steel and concrete, and that's what it is. But in mass timber, it's got to be a little bit more of a hands-on discussion at the beginning. If the owner wants mass timber or the design wants to go that route, it's all right, we need the structural engineer involved extremely early to see what's possible with that design, to make sure you're not having to, like, I just have nightmares of, okay, now I have to redesign it in CDs because it's way over
Yeah.
budget, just because of bay size lengths not adding up. And you don't usually get that information from the contractor of saying, hey, just reduce the bay a foot and you'll save $1 million or whatever amount. Like, they're just like, nope, you're X number
Yeah.
way over budget. And so sometimes it can be helpful to have that information ahead of time and making sure we don't design ourselves out of having it in our projects.
Right. No, you're absolutely right. Like, column spacing or bay sizing it's a pretty fundamental aspect of a building's design, right? But it's often overlooked because it's something that's hidden in the end condition, right? It's like lay out the building, and then the structural engineer's job often is, where can we locate columns, in
Mm-hmm.
walls to avoid being seen, if you will. Versus with mass timber, I mean, first of all, sometimes you want to express the structure, you want to see the structure. So that might be a different thought process. But then also, if you are seeing the structure, not only is it how do you design it, from an efficiency standpoint, like the base sizing you talked about, but it's also because, especially in something like an office building or an institutional where you might see multiple bays just by standing in one spot, it's that much more important to make it kind of look consistent and clean and repeatable, because you're not, like in a structural steel building, you might have, different column grids just to hide things within walls. Whereas with mass timber, you wouldn't want this kind of irregular pattern of columns and beams and whatnot, not only from a cost standpoint, but just from a visual, aesthetic standpoint. You want it to look clean and consistent. So it's another reason that the column spacing, location of columns is pretty fundamental on a mass timber building. And like you said, engaging the engineer early to help with those initial decisions is really important.
Yeah. And getting into your own business, Mass Timber Advisors, what services are you providing with that company?
Yeah, I think a lot of it is going to be fluid to try to figure that out along the way, but I can certainly see where a lot of the interest is already and where I would like, a lot of the work to be. And I see that sort of in two different aspects, one of which is a project specific aspect. So, it could be a lot of the things that we've talked about so far, and then those in much more depth where, a developer wants to use mass timber, or at least is interested in using mass timber, but they never have before, or their design team never has before. And they really want somebody to be deeply involved throughout the process and kind of, help hold their hand along the way to help them understand, everything from finding an experienced team to understanding all the nuances of the building code to actually doing the design process with them, engaging other folks that might be able to help throughout the way. So I think that side of it for sure is of interest. And that's something that, I think I'll really enjoy getting back to the project specific side, from my structural consulting days of being involved in a project really from the very start to the very finish. I think then the other aspect of it is more, I guess, what I would call industry or industry related type of work. And what I mean there is, mass timber is a rapidly growing industry. So that means there's new companies getting into the mass timber space all the time. And those could be companies that are making, anything from mass timber products, the wood products to hardware fastener products to coatings and sealants to, fire protecting systems to erection systems to software technology, virtual reality platforms. There's a lot that is growing with mass timber and will continue to need to grow along with a growing, market and industry itself. So, working with some of those companies to help them understand what is mass timber here and how is it done? How can they enter the market? What types of technical literature are they going to need to come up with to have rapid approvals, permit approvals on projects? Those types of things, understanding how the code allows mass timber to be used. And, so I think there's a lot there that's an opportunity to be involved with helping advance, the use of mass timber for sure.
Yeah, and it sounded like there's a lot of resources out there, but they're scattered. There's doesn't seem to be like a tried and true like how to or getting everybody up to speed. Everybody's kind of rapidly moving at a quick pace to figure out the system, understand what works, what doesn't work, how to detail it. So I definitely think from the sounds of it that that's a big part.
Yeah, for sure. There's a lot of good resources like through Woodworks, through Think Wood, through FP Innovations is an organization in Canada that has a lot of great resources. And then, like to your point, there have been a lot of other, oftentimes just, consulting companies or architects or other people who have gone through a few projects themselves and have lessons learned. And they're sharing that information. The mass timber is a very, like, I guess I would say open or collaborative industry where, it could be just lessons learned from this one project, or it could be like there's a specialty consulting firm called RDH, and they've created a couple of really good guides on the moisture aspects of mass timber. How do you protect it from moisture during construction? How do you detail a building envelope that protects it long term? There's some really good resources out there on acoustics design with mass timber. So yeah, definitely the industry trade organizations have really good information, as well as, just other developers, architects, and engineers who have produced their own literature.
Yeah. What is the recommendation for protecting it during construction?
Well, if you read that document, you'll see that there is a variety of ways to approach it. So I probably can't give you just one, but the variety of approaches, I guess I would say, is maybe at one end of the spectrum, do just about nothing, meaning don't apply additional protecting materials, and kind of just let it be. And then you probably end up with some moisture staining. So you have some sanding or some washing. I'm not saying that is a good approach, but that is at one end of the spectrum. Sort of a middle approach is, sealing sealants or coatings on the top side of the timber. So as it's exposed to rain, especially, and also UV, it protects it in some regard. A lot of jobs are where two panels come together, or like where there's a box out in a panel for a column to go through, doing some type of tape so that you're not getting moisture infiltration between the panels, because oftentimes that then kind of wicks on the underside of the panel and you get some moisture staining there. And then the far end of the spectrum probably is just a full sheet membrane where you're covering the entire top surface of the mass timber. And sometimes that's done on projects like just at the roof level, and it kind of acts as sort of both temporary roof as well as part of the long-term building envelope. For taller projects, they might be doing that like every second or third floor, to act as a means of buffering the moisture infiltration during construction. Of course, it also depends a lot on where the job is, and what the anticipated weather is going to be during construction.
So it's a little bit more on the staining from water damage. I was thinking, is shrinkage on like another issue because of the water penetration in terms of that filtering through as it's getting built?
It can be. It can be. I would say it's not as big a concern as it is on a pure light wood frame project, but it is a concern and it should be thought through. Typically, mass timber products, first of all, are manufactured to
Mm-hmm.
lower moisture contents. Like you might buy a 2 by stud from your local lumberyard, you probably see a stamp on it that might say KD19. That means kiln dried 19. 19 is moisture content. So versus like mass timber is manufactured, depending on the product, anywhere from say 6 to 14% moisture content. So it's manufactured at a much lower moisture content to start with. The reason that that's important is because ultimately it's after you close in the building, it's going to settle down to what's called an equilibrium moisture content. And for most interior conditioned spaces, that's going to be somewhere around 9 to 12%. So the closer you are to that 9 to 12% when the products get to the job site and are installed, the less shrinkage that's going to occur. Because if there's no increase or decrease in moisture content, there's no shrinkage or
Mm-hmm.
expansion. Versus if it settles down to 10%, but it started at 25, like that's when you get a significant amount of shrinkage. So the fact that it's manufactured the lower moisture contents to begin with is helpful. And then also, just the fact that you're typically, depending on the product, but you're typically having some type of cross orientation with CLT anyways, where that helps provide some dimensional
Mm-hmm.
stability. Whereas, if the lumber is all running one direction, it's going to shrink all uniformly. Versus like CLT, you have these interlocking layers. So one surface might try to shrink, but the other surface kind of restrains that because it would go, um, it would basically restrain it because of the different orientation of the grain. So it is a more dimensionally stable product. CLT is, anyway. So it can shrink, it can expand too, and it should be something that's thought through in the design, but it's usually not as significant amounts of movement as like a pure light wood frame building.
Gotcha. Welcome back. And this time we're going to take one step further into that policy side, and we're going to bring in Corey Squire. He was episode number 11. And this one, he did a lot of work with AIA COAT, which is the more energy and environmental side of the committees within the AIA. He has been a sustainability consultant. He has been within firms and being a sustainability leader. But one of the big things and frameworks that he's created with a team of professionals is the AIA Framework of Excellence. So, pulling together how we focus our design awards to making sure that they are focused in on sustainable practices and purposes and creating that full framework and making sure we are creating holistic architecture that has a purpose, meaning, and intention behind it as well. So, listen in a little bit on Corey's story. Let's dive into your book a little bit since you brought it up. So, it's a brand new book. I think it came out in early November.
Yeah, it
Um,
actually published last week when we're
yeah.
recording this. Yeah.
So I think this will come out. I believe I have it on the docket for January. So if you haven't gotten it yet, it's been on the shelves. And if it hasn't been in your Christmas stocking, you can check it out. But it's People, Planet, Design, a practical guide to realizing architecture's potential. So the book is about focusing on professionals learning about sustainability and the importance of it. How
I would say that the audience is broader than that. It could be students, it could be professionals, but it's basically this idea of what is sustainability, what are we aiming for, how do we get there? Kind of like trying to create kind of like the complete package.
Yeah. Would it be helpful for clients? Because you did mention it's that communication to clients and the value of it. Would it also be helpful for them?
I think so. I think that clients and architects, not some clients are obviously architects, but a
Yeah.
lot of them are not, and we kind of have a very different background and experience. Maybe even speak different languages, almost. And I think that what the book does from the perspective of a client is describes kind of what's possible, what's out there, what they could achieve in their buildings, maybe things that they aren't currently focused on or thinking about, and it could help clients ask better questions and get more out of their buildings.
What inspired you to write the book?
I was so at this time when I started writing, I was consulting full time with Department of Sustainability, and I felt like a lot of firms, diverse firms, different parts of the country, different sizes, different focuses, were all kind of asking the same question, which was, we really want to focus on sustainability. What do we do now? And it was a question that I spent a lot of time thinking about. Before I started consulting, I spent a lot of time thinking about this question from the perspective of all these different firms I was working with. But I thought the message was, it was something that people were curious. I wanted to get it out. I knew a lot of firms were struggling with the same idea, even the ones that I wasn't speaking to or working with or were aware of me or I was aware of them. So, and I didn't think that, I didn't think there's something else like it. I think there's a lot of books out there that describe sustainable design strategies, and this book covers that as well. But this also digs into how to organize practice around sustainability, how to identify what are the specific outcomes that we want to achieve when we think about sustainability. So we know that we're not going to get to like carbon reduction with design strategies alone. We already have all the design strategies. We basically know them, but we're not always able to implement them on projects. So what are the cultural, like interpersonal kind of reasons for that, and how can we get around them, and how can we kind of advance some of these goals that a lot of people have?
Yeah. No, I just think of, I forget the exact title of the book I had to get in college, but it's a white book with like a square image in the front. It was like light,
Some of the
something
light.
at the time. Yes. And it's like, I think of that book whenever you describe this one, but in more like practical terms.
I mean, Something with the Light is a great book. It was first published in the mid 80s. My hope is that this is the next iteration of kind of formalizing sustainability.
That would be awesome, and just have it on everybody's shelves. I know it's in that cabinet if I needed to go get it. Because like I know exactly where it is. In terms of pulling back on like your career side, how do you balance your time between Bora and the consulting firm? How's that work-life balance?
Well, I think so. It's very important to me that architecture firms that are that want to improve on sustainability, and want me to help. Like, it's very important to me that I'm available to answer questions, basically. So when I was consulting full time, it was my full time job. But now I'm not doing as like in-depth workshops with firms. My hope is that the book actually covers a lot of that for me. But I am totally available for questions. So I speak to a lot of firms. If people have questions about like, what should we be prioritizing within a design process? How do you get started on post-occupancy? Or like, what should we be focused on, right? How important is FSC wood, for instance? Like, what software should we be using for building performance simulation? So I mostly have kind of phone consultations, and that could just be whenever throughout the day, right? Evenings, weekends, whatever.
Yeah, because it's always balancing. I guess the hard part's like during work hours. Like I always try to, all my stuff's more in the evenings. So That's why I was curious. But really getting that like perception side to make sure, you know, what we designed helped the people of the space. And if it didn't, how can we learn from it?
The first thing I would say is like, post-occupancy is a pretty low bar. People often work themselves up and like, we have to do this very thorough scientific evaluation. And you really don't. Showing up at a completed building and making intentional observations, like, are people sitting in the parts of the building what we expected them to be sitting? Maybe they are. Maybe people pulled over additional chairs because it's such a great environment that then more people want to spend time there. Maybe nobody is where we thought they were going to be, and maybe it's too glary, right? Maybe it's too loud, right? We can understand that. So, showing up at a building and just taking pictures, observing, maybe talking to people. I mean, you can learn so much in just an hour. Same with utility bills. Ask for a year of utility bills, calculate an EUI, compare that back to either a benchmark or an energy model. It's like, is this building using more energy or less energy than we thought? And then from there, you can be like, well, why is that, right? It's using less energy. Is that because it's not fully occupied? Or is it using more energy? And is that because we made some big mistake? Or is it because the building is so wonderful that it's getting twice as much use as we anticipated? And that really
Yeah.
matters, right? If you find that it's using more energy, it's like you got to know whether which one of those it is.
Yeah, if it's a design or a people thing and how they're
Right.
using it.
Yeah, but overall, I mean, there's I like to describe post as like this three-legged stool where in a building we use energy to alter the environment to improve the experience of people. So
Hmm.
we want to make sure that people have a good experience. People have a good experience depending on partially at least the environment that they're in, which is the light, the sound, um, the temperature, their interaction with the physical space. And for the most part, we use energy to like alter the environment. So I think you have to understand those three things. Now, again, I said it's a low bar. You can understand one of those things. You can study this and not that, and it's fine. You'll learn something. But for the full picture, it's like if you're using so much energy that you're overcooling a building so that people are less comfortable, right? That's like that would
Yeah.
be a very bad outcome, right? In theory, you can make people happier by using less energy. So yeah, understanding the interaction between those three things, and then if you can connect that back to certain design decisions and see whether those are good or bad, and how can you then take those lessons into future projects.
Yeah. And so you always go on site for those, because I know other architects that are super busy will tend to like, hey, let's try to send out surveys to people and see who answers things. I'm like, if people don't answer them or you don't get that why behind something, if somebody doesn't like a space, they could just say, no, I don't like the space, or give it a 1, but then you don't know if it's glare or if it's too loud or too bright. Like,
Yeah, I think you're right. I mean, surveys could be useful, but you need the context behind the answers to gain anything from it.
yeah, definitely. Um, Shifting over to some of your work you do outside of all of the Bora and your consulting firm, I know you're an active AIA member with COAT, so it's Community on the Environment. Can you tell us a little bit about what you're doing on the committee, what that committee is about, if anybody has no idea what COAT is?
Well, I'm currently not on the Committee on the Environment. I was on the National Committee on the Environment for the AIA from 2018 to 2021. Um, and it's a role that you apply to. It's a 3-year term. The group is about 10 people, and what they really do is kind of lead sustainability from the perspective of the institute. And when I was a member of the Committee on the Environment Advisory Group, which is what the group is called, um, my big focus was the framework for design excellence. So I was the lead author of the framework. I wrote most of that in around 2018, and then in 2019, our group, the Committee on the Environment Advisory Group, kind of created a resolution, sent that to the board of directors of the AIA, and we asked for a floor vote that the institute would like formally adopt the framework for design excellence
Mm-hmm.
as kind of the definition of good design. And that vote passed. So we do have a formal kind of framework for design excellence. And if you're not familiar with it, check it out on the AI's website, but it walks through design for integration, design for energy, design for water, design for change. Basically, the idea behind it is that good design is defined by solving these problems, like addressing energy, addressing human health, addressing equity, and it's also made its way into design award programs. So
Yep.
the Committee on the Environment, the COAT Top 10 was the first one, but national design awards, local design awards have been adopting this. And it's been a pretty powerful tool for kind of shifting this focus, maybe away from kind of celebrating an image towards celebrating the impact and the outcomes that we can have through our design decisions.
Yeah, I'll leave a link below so anybody can go directly to that. I didn't know you were one of the authors of it, so that's a fun thing. I know our firm uses that for our design practices and doing design charrettes and letting that lead us from the start of a project.
Yeah, I'm so
So,
glad to hear that.
yeah, talk about impact.
Yeah, no, I'm really glad to hear that you're using it. I think it's a valuable tool, and it was a great team of people who put that together, and it's really had legs, which I've been excited about.
Yeah, and going back to like your first point when we started talking on, shifting from your education on sustainability and then going for architecture because that's where you can make an impact. That is one little piece that you made an impact, because I work for a national firm And that's part of our design process now, and we're all over the country.
Yeah, well,
So,
that's wonderful to hear that. So, and maybe I could give that as for advice. Like, sustainability is a new enough field, sustainability and architecture, that there are a lot of opportunities to have a big impact.
do you have any advice for young professionals looking to get more involved with the Committee on the Environment? Or
So most cities have a local COAT chapter. Before I applied for and got accepted to join the national committee, I was the chair of Committee on the Environment San Antonio, and it was a small group. San Antonio is I guess a medium-sized city. We had maybe 10 members or so, but we did a lot of good work there, and we created some good educational programming around the topics that we thought were very important. And I know that COAT chapters around the country are doing really, really good work. So I definitely recommend getting involved with the local COAT chapter. There's a national network. Mm-hmm. So there's if you're involved with COAT, the national committee kind of gets all the local committees on a call once a quarter to kind of coordinate efforts between the various chapters. It's a really good community, and I'm always impressed by what the various local COAT groups are kind of creating in their communities.
Yeah, definitely. Has there been an organization that's left the biggest impact on you on your journey so far?
I mean, the AI has really been like a nice home for me. So I got very involved with the local AI chapter when I lived in San Antonio, and that opened doors to me at the national level. And it's just such a great community. I mean, all AIA work is volunteer work. So people do it because they're really dedicated to both advancing the profession, advancing kind of opportunities for their fellow architects, but also improving the world. Architecture has huge ability for impact, and everybody touches buildings and urban environments in different ways. So kind of small changes at the level of the profession can have really profound changes in the built environment. So part of that is like advocating for various codes, creating educational programs around anything like, I don't know, healthy materials or carbon reduction or whatever else. So it's been in terms of kind of my career path, the AI has been a really important part of that.
Welcome back. And I got one more professional for you. So this is Scott Farbman. He was episode number 80. He has taken more of the architectural education route, but finding he likes the engineering side a little bit more. So he always says he bridges the gap between architecture and engineering, but he is coming in with a building science side and environmental testing and understanding air quality and how all of this is so important on how we live and breathe and interact with our buildings. And now he's even more on the codes and policy side. So outside of the day-to-day architecture firms and transitioning to what it could mean to really impact and influence the codes and policies for our cities, states, and nation as we step into new eras of the code and making sure that we're always striving to do better. So let's jump over and listen to Corey's story.
Collecting data and sharing it online and trying to hold building operators more accountable for what should really be a norm is good indoor air quality wherever you are. And I think it's air quality in particular is something that we take for granted. It's not visible, doesn't always appear obvious to us if the air quality is bad, unless we're in like a Southern California wildfire situation. But you just can't see it, so you don't know, and you don't know until you start monitoring it, and it could be impairing you either health-wise or cognitively from like a performance perspective, doing work effectively and thinking and doing tasks and stuff like that.
Yeah, I've even seen more research going to be a new mom, and so all algorithms are sending me data on children. Yes. And it's like you see things of infants breaking out with skin conditions, and they see all these specialists, and it's actually mold within their home that was causing it. It wasn't like they're allergic to something like food wise or a medicine. It is our environment affecting it. And once they got rid of the mold, everything cleared away. And so it was them advocating to teach people that your built environment's actually really important for your health and for sensitive members of the community, senior citizens, infants. They're all within that range, but it may not affect you personally if you don't have particular instances with it. So
yeah, and the mold stuff is scary, and it's incredibly complicated too, because it's not just about your individual choices or behaviors in your home or building. It's how is the building built? Like, how much control over the indoor environment do you have as a building occupant? How well constructed is the building? Are you getting condensation in your walls? There's so much that could be happening. 99% of it outside of probably the typical person's ability to understand, and a lot of it outside of the ability for designers to understand too. It's an incredibly complicated building science, and I'm just so grateful that there are, standard wall assemblies and strategies and resources out there to help people make the right decisions just day one on building design, because that's where it all starts.
Yeah, because it really needs to have that foundation between systems and what is the best for that region and the occupants, but then what's the best system from an exterior perspective. Like, these things all come together, and I feel like everybody just wants to dive into the fun diagram like so quickly. I'm like, well, what are the fundamentals?
Magic arrows and your colors.
Yeah, and the owners are relying on us to make sure that we're giving them a high quality building and they don't question those things, I think, as much, to make sure that we've done our research in the design side, pulled it all together to know it works, and give the proper information to the construction team so they can build this right. And we've got the information across the entire industry.
Yeah. And even if it's built right, when it's passed off, the people using it could be using it wrong.
Exactly.
And then you're just in the same problem too. It's from both sides. And again, it's really, really complicated. It's unfortunate that some of these things compete against each other. So for example, if it's wintertime and it's really cold out, the more indoor humidity you have in your house or your space, the higher likelihood you might have for condensation to occur either on your windows. Like, anyone in a cold climate over the past couple of weeks probably have seen some moisture start accumulating on their windows. That could be happening inside the walls too. So what's kind of the knee-jerk reaction is, let's get our humidity down as low as possible so this doesn't happen. But once you cross a certain threshold, then you're impacting us from a human health perspective. Too low of humidity could cause respiratory problems. It could cause you to have really dry mucous membranes, and your lips are going to get dry, and like you could become more susceptible to getting sick. And like, it's just so complicated and really unfortunate. I wish it was easier for us to just have like a safe, healthy environment.
Yeah. And we've got so many different climates in the States, let alone across the globe, that, you have to pivot and change. And as global warming happens, things change. Those in Florida were not expecting a bunch of snow recently. Right. So those buildings weren't meant to have, the snow loads on the roof and different things. They're meant for the hurricanes. So you never know, as we have to adapt and change.
Yeah, even the buildings we design in the colder climates, we design them to be able to heat to like 99% of the hours out of the year. And you, like, there's 1% left over where it's just going to be really freaking cold, and you just got to do your best. And that's just kind of how we approach things. It's not always great.
Yeah. And now you're over on the policy side. I know it's more of a new role for you, but how's your day-to-day different? What's it like really diving into the codes and having the ability to make changes?
Yeah, it's been really interesting to switch gears. I will say that 100% I miss working at the building level, even just a couple months in. It's just not the same. I don't get the same kind of reward out of working on a really great project. I work with a lot of great people, but it's not quite the same team composure and team makeup of so many different disciplines and different people bringing expertise to like make a project work. That's not quite the same. But what I find to be incredibly rewarding is that the work I am now involved in on the code side of things, if I can make it could be 0.1% improvement, but like apply that to the number of buildings across the country or the state that needs to meet that 0.1% improvement, and the impact is just exponentially more than I could have ever done on the practice side, working on several buildings a year. So that the change is fundamental. And it's been fun, it's been interesting, and it's been rewarding, but there are things that I do miss about working on the building practice side of things for sure. The day of the day, I don't think is too different. I'm still kind of in a research and kind of project managerial type position. I'm helping deliver code development proposals and managing deliverables and process and stuff like that. So a lot of the day is pretty similar. It's just like the type of work is slightly different at a scale level. It really is just like micro versus macro scale stuff.
Yeah, I'm even connecting it back to when you were talking about like air quality. You can't see the impact that it makes like we would, being on a project team and seeing a project from start to finish, but being at that larger scale level and you can't even see the impact you're having on projects directly. It's a different mindset.
It is a different mindset. But fortunately, the company I'm at now is very impacts driven, and they do as much analysis as possible to extrapolate the impact that even these small changes are having at the code level. And they know how many buildings it could impact and do like monthly annual reports where you start to see like the numbers. Mm-hmm. When you see the numbers, it just makes it that much more real. Like the tons of carbon or greenhouse gas emissions that are avoided because of some of the code development work, or the amount of kilowatt hours or megawatt hours we've been able to cut out because of energy efficiency programs, or the number of heat pumps we've been able to put into low income and disadvantaged communities because of the incentive programs that we're administering. It's just, it's similar stuff, but it just hits different. It's really awesome. I'm really loving it so far.
Yeah. So does the company connect more to that state level, or are they partnering with A&E firms on projects? Like even beyond what your role is, how's that connecting?
It's a great question. It kind of runs the gambit. It really depends what category of the company we're working in and what sorts of things we're trying to do. It's kind of every scale right now: city scale, state scale, and federal, kind of across the country. I think in terms of having the most impact, though, I'm still pretty fresh here, but from my observation so far, I think we have the most impact at like a state level, or even maybe a city level. And it's funny you bring it up. I'm working on a project now. We're looking at embodied carbon as a potential policy measure and incentive program. And we need to talk to subject matter experts in the embodied carbon world. So what's the first thing I do? I call up all my friends and colleagues that I've met over the years doing embodied carbon analyses and carbon modeling and life cycle assessment in the professional practice industry. And I say, hey, we're looking for partners to do this really cool project. Do you want to get involved? So I'm already kind of full circle connecting back, and it's been really great to kind of flex those muscles again and still have value to all the work I did in my previous roles. It is still finding a way to pop up now today in this new role.
Welcome back. I hope you enjoyed learning from all of my guests and the ones I've pulled out regarding codes and policy. So if this is something you want to take your career, reach out to any of these professionals. They are more than happy to speak with you and tell you more about their story, give you more specific advice on something you want to specialize in. But if you need a recap, it was Ricky McLain. He was the heavy timber structural engineer, and he was episode number 36. Corey Squire is the sustainability consultant, AIA COAT, and AIA Framework of Excellence, and Corey was episode number 11. And finally, Scott Farbman, which was episode number 80, where he bridges the gap between architecture and engineering and pulling that together to work on the policy and code side. So hopefully you enjoyed this episode, and I'll see you in the next one. I hope you enjoyed our discussion today. Learn some advice to take with you and see how our industry is all tied together to create the world around us. Check out the description below for any links or resources we discussed. If you liked the episode, please do me a favor and hit the subscribe button. Give me a thumbs up and leave a comment below. It really helps others be able to discover this resource and support finding that career path that best works for them. If you know someone that has inspired your own career that you'd like me to interview, let me know in the comments below, or you can reach out to me via my website or LinkedIn. I'd be happy to share their story or your own. Thank you again, and I cannot wait for the next career story I get to share with you next week.